till 26 June 2022 on fundamental research using application software. The program has been organized by the Faculty of Management Studies of Dr. B.C. Engineering College, Durgapur, in association with Operations Research Society of India, Durgapur Chapter, ORSID. We start our August program with a ceremonial lighting of the lamp. For this, we request our Honorable Chief Guest, Professor Dr. Gautam Bandopadhyay, Associate Professor of NIT Durgapur, our HOD Professor Dr. Shondrup Siddhanto and Professor Dr. Anita Pal, Honorary Secretary ORSID, to kindly proceed to light the lamp. I would also like to request Professor Krishna Roy to proceed towards lighting of lamp. The purpose of faculty development programs is to impart knowledge-based training in order to upgrade the skill of the teaching fraternity employed in various disciplines. Our 7-year faculty development program focuses on the basics of research and the application of various tools and techniques to satisfy the appetite of the researchers for writing research papers. The program is an amalgamation of both theoretical and empirical exposition of data. This will help us to be well acquainted with a wide variety of data analysis software tools. I now call upon Professor Krishna Roy, convener of Faculty Development Program, to kindly deliver the inaugural speech. Please.
I don't think I need the mic, but still. I think otherwise also, am I audible without the mic? So let me speak without the mic. Thank you. See, reputed academic institutions engage in research to ensure better learning through discovery. This in turn contributes directly or indirectly to the primary mission of teaching. And you are unable to hear. Okay. So I'll just start. Usually reputed educational institutions, they engage in research to ensure better learning through discovery. This in turn actually contributes directly or indirectly to the primary mission of teaching and knowledge sharing. It goes without saying that the advancement of knowledge through discovery, innovation and creativity is essential to empower a teacher and develop his or her teaching acumen. Research as a process of knowledge building inspires personal growth and development in individuals as well as groups. Teachers bring their expertise to their classroom, and by actively sharing the knowledge they have gained through research, they build a professional community and shape the minds within this community. Any teacher who has asked a question, deemed essential to practice and use a systematic method to find an answer has actually engaged in a form of research. But to conduct research successfully, a good number of tools and techniques are available in today's era, and a proficiency in handling these tools can be of great help to a teacher as a researcher. With the rapid development in computer science, like all fields of life have been impacted by computer science, and research has not remained untouched by its influence. Any academic institution that wants to leave its footprint in the path of educational supremacy must create opportunities for its teachers to develop as good researchers. With this objective in mind, Faculty of Management Studies, Dr. B.C. Roy Engineering College has initiated this 7 days FDP titled Fundamental Research Using Application Software. We shall be successful in our mission if the participants improve their research skills as a consequence. We are indebted to Dr. Gautam Banerjee, Dr. Amar Mishra, Dr. Anita Paul, and Dr. Omlan Ghosh for their support in our endeavor. Thank you so much.
Thank you, madam, for your valuable speech. This was very informative. I would now like to invite our HOD, Professor Dr. Shomru Siddhanta, to kindly deliver his welcome address. Sir, please.
Thank you, ma'am. Very good morning to all of you. Am I audible? So, Dr. Gautam Bandopadhyay, Sir, Associate Professor of Department of Management Studies, NIT Durgapur, and President of ORSI Durgapur Chapter. Dr. Anita Paul, Assistant Professor, Department of Mathematics in NIT Durgapur, and Honorary Secretary of ORSID, and Professor Krishna Roy and all other faculty members of FMS, and most valued participants who have come from all around the state. I take this opportunity to welcome all of you to this 7-day long faculty development program titled Fundamental Research Using Application Software. Now, the primary objective of this FDP is twofold. One is that many times when we check up, our gold standard is like ABDC journals, and we kind of, whenever we write research articles, we check up that list and we try and publish in ABDC listed journals. Even if we have published half a dozen, we think we have done a good job. So when we do so, either in Scopus or ABDC listed journals, whenever if it is a primary data and we need to analyze the primary data, the certain techniques that are used, like structural equation modeling and confirmatory factor analysis, are being extensively used, and these are the practices that are happening right now. So if only we have an exploratory factor analysis, it might not be enough to get our articles published there. So this was one objective, that we need to have a hands-on practical training of these techniques with the help of softwares like SPSS, Amos, and JMOV. Second thing that I'll tell you is that about the softwares that we thought of, SPSS and Amos are obviously, we need to have license and all that, or at least a trial version. But even if we don't have that, JMOV is open source. I know R is also that, but then you need to know the programs, and this is more menu-driven. So this was another objective behind including free or open source software, and therefore we designed the FDP in this manner. So I hope this 7-day long exercise will be helpful to each one of us, and it will lead us to publish good articles in journals of review. So with that, once again I welcome all of you, and hope we have a great fruitful learning experience. Thanks.
Thank you, sir, for your encouraging and motivating words. Now, may I now invite Professor Dr. Anita Paul, Associate Professor, Department of Management Studies, NIT Durgapur, and Executive Committee Member of ORSI Durgapur, to enlighten us about the importance of research and ORSID's contribution in this field. Please, ma'am.
Good morning all. Thank you very much, organizers, for giving me this opportunity. So I will welcome you all to this 7 days FDP on behalf of ORSI Durgapur chapter. And it is being organized by Dr. Misira Engineering College, Durgapur, jointly in collaboration with Operational Research Society of India, ORSI Durgapur chapter, which is going to end from 20 to 26 June 2022. The aim of this FDP is to provide a platform to young researchers, academicians, and people belonging to various domains of business studies for sharing innovative research ideas and experiences. Operations research is an important tool used to solve complex problems under uncertainty. Operations research is a problem-solving and decision-taking technique. It is considered a kit of scientific and programmable rules which provides the management a quantitative basis for decisions concerning the operation under its control. In operations research, research techniques, scientific methods are employed for the analysis and also for studying the current and future problems. Thus, operations research offers attractive plans for a problem to the management for taking decisions. Operations research has wide application in various fields like finance, budgeting, investment, economics, marketing, purchasing, production management, personnel management, research and development. So let us now just come to the history of ORSI, Operational Research Society of India. It was founded in 1957 and ORSI is having 16 number of chapters overall India, and headquarters are in Kolkata. Here in Durgapur we are also having one chapter. So ORSI Durgapur chapter is a very active chapter. So we have more than 55 members in this chapter. Over the years we are organizing many seminars, conferences, workshops. A few I will just let you know. Recently we had webinar on application of data science and soft skill, which was held on 26-27 September 2021. It was a national webinar and more than 50 participants participated from overall India. We also organized webinar on indexing and referencing of journals in March 2021. ORSI Durgapur chapter has organized webinar on optimization problem and its application, which was held in April 2021. We also organized optimization through real-life application and implementations during July 2021. ORSI Durgapur chapter has organized webinar on multi-criteria decision making and applications during September 2021. Recently we had a webinar on solving real-life problems with nonlinear optimization models in April 2022, and many more events are upcoming. We have our website. If you want, you can visit the website. Presently, Professor Gautam Bandopadhyay is sitting here. We all have seen. He is president of our chapter. Professor Chitotosh Bhattacharya and Professor Krishna Basu, they are vice presidents, and myself, Dr. Anita Pal, I am the honorary secretary of the chapter. There are many more active members in the society who are actively taking part in organizing such programs. With these few words, I would like to conclude. I hope this FDP will be very fruitful to all of you. And the organizers are trying very hard. They are working very hard to make this a successful one. All the best. Thank you so much.
Thank you, madam, for your valuable speech, and that was very informative. Now, Professor Dr. Anita Pal is an associate professor of Department of Mathematics, NIT Durgapur, and she is an honorary secretary of ORSI Durgapur chapter. Now, finally, we have come to the much awaited moment for which we have gathered here. To start the session, a brief intro about Professor Dr. Gautam Bandopadhyay is imperative. Dr. Gautam Bandopadhyay is an associate professor in Department of Management Studies, National Institute of Technology, has completed his PhD Management Studies from Durgapur University. He is MICWAI and FCMA qualified from ICWAI and also graduated in Operations Research from Operational Society of India. He completed his postgraduate diploma in computer application from Regional Computer Center, Durgapur University, India. His research works are published in numerous foreign peer-reviewed journals and Indian peer-reviewed journals. He has successfully guided 30 numbers of PhD scholars, and 6 scholars are presently working under his guidance. His research mainly involves financial capital market and portfolio optimization using different soft computing techniques such as fuzzy code programming, fuzzy time series, different statistical multivariate techniques, and optimization techniques like DEA using SPSS, eViews, and Lingo softwares, and also by RStudio for big data analysis. He has conducted numerous workshops, short-term course, and summer of the Winter School, especially in the area of research methodology in different universities and in different P School of Management using the softwares SPSS, eViews, RStudio, and Lingo. He was former head of the department in Department of Management Studies, National Institute of Technology, and acted as expert member for inspection of different management colleges under West Bengal University of Technology. Before coming to academics, he had 13 years of experience in consultancy in software field. This was a very brief introduction of Professor Bandopadhyay. In today's session, Professor Bandopadhyay shall conduct a session on the basics of statistics, the use of SPSS software, concepts of scaling and data mining using OLAP, and give us a detailed overview of advanced statistics that will be followed by a question and answer session. May I now request Professor Bandopadhyay to kindly take the session.
So good morning to all of you. Good morning to all of you. So first of all, I'd like to thank B.Tech Engineering College for inviting me, and definitely to be exposed to interacting with the august audience. And I'd like to thank Professor Sunduk, Siddhartha, HOD, and Professor Isnaraj, and all other faculty members of B.Tech Engineering College. And before starting my presentation, so I'd like to say something, because we are all the students of research, and I believe, this is my belief, and one thing, since we are all the faculties, don't think I am taking the class. Anytime you will interact with me, so if I know, then I definitely give the answers. If I don't know, so definitely then I have to learn. Because learning no end at all. So I believe in one formula before studying my class. Can I get some? My voice is audible to all of you. So I am not taking mine. I am not taking any mine. But I am no need of it. Here, last. Can you hear? Achha. No, now okay. So I think we are. Hello. Last. Okay. So, I would like to say something before starting. Don't think, I am taking the class. Then you will feel bored. Number one. Number two, so when I tell something, don't believe. Don't believe things. So you think logically. Yeah, I'm saying right or wrong. This is the thing. Number three, I believe one thing. If you don't know the fundamental basic, how is profit? This is my next thing. So today, when you start the class, basically we start the class of research. We start the class of research. So, my perception I am sharing. So when I start my research in the 2008, I thought that how I can start research. Basically, we are still different from different domains. Some from economics, some from marketing, some from finance, some from economics, some from systems. Okay, and definitely some from the social science background, from education, all science, anything. So I thought of it, there are so many domains. So when you start any research, how can I divide in the total domain into the research field? Because I don't know, as a student of mathematics, statistics and what, your domain. It's not possible. So that's why, what I will tell you, today's my class basically based on some data analysis. Because we can collect the data from the any field. So when you start any research, basically you know that it's basically qualitative and quantitative. But today's discussion, basically today's class based on quantitative research, and tomorrow I try my level best to give some knowledge about the qualitative research. I'll try my level best. So when I start this research, then I thought, how can we start? Because every research or every having some kind of the paper, kind of the thesis. So, and overall, how can I formulate or how can I flowchart, making some flowchart. So for everything, if you have some algorithm, so then you can write some code. You know it. If it's an algorithm. Suppose if there is no algorithm, no program. I am giving a simple example. If you ask me, can you find the prime number algorithm? Because there is no algorithm. So definitely for the finding the prime number, so I think there is no algorithm, we cannot make any perfect program. Okay. So when you write any program, that must be algorithm. So when we are studying research, any kind of research, there must be algorithm. So I thought, how we can define this algorithm? So I devised the algorithm into 5 points, basically.
1, 2, 3, 4.
So what are the 5 points? The first one is, for any research, there is basically domain. And this domain, we know the domain, because we are the domain expert. And for the domain, there are some the broad heading, some the sub heading. So we start our research with some broad heading, then divide into sub. That means we know our domain. What is the first one? From the domain, we can find some research question. So this is my research question. Now what is my second part? And for the all types of domain, we have to go for the differentiating. Everyone knows. That is the second one, which is very important. And nowadays, in the 2022, this is the era is converted into S era. That is the systematic research. Initially, when we started our research, at that time it was called era, literature. But now it is converted into the systematic, which is most meaningful. And this is the basically the second part. And from the second part, you come to the third. So what is the third part? Because this is the fundamental concept. This is the fundamental concept, theoretical research. For the what is the third one? Operational. Operational part, how do you form the objective of it? How do you form the hypothesis of it? So this is the third part, operational. So after this third part, this G part is very important. This is for, for domain income. And the fourth part is the data analysis and methodology. This is my today's topic. Today's topic is the data analysis and methodology. And if we know the correct data analysis, and if we know the correct methodology, so definitely our findings, results, discussion, conclusion will be found. Tends to come. tends to cause. And I'm telling you, every research having some limitation that we know. And definitely since there is the limitation, that's why it's called research. And that's why limitation means there is a future scope. And from future scope, again we are starting our future research. And ultimately, you know, there are some reforms. This is the basic background of the research. But today, not possible for me to discuss about the literature review, to discuss about the SLR, that is the systematic literature review. That is the beyond of the scope. And okay, and today basically, you know, I start the initial research method that is about the data. And the problem is, when we started our research, then that is in the year 2008. So that is one advantage. Advantage is, only there is a single software. Single software, maybe the 2 or 3 software, the well-known common software in this case. That is the advantage. And what the problem we are facing in 2022, there are so many software. So many software. Someone can do you know Tabula? Do you know Power.BI? Do you know Stata? Do you know SPS? Do you know Utilities? Do you know R? Do you know Python? Is it possible for a human being to know all the software? So my question is, it's my perception I am sharing. Software, any kind of software is basically tool. Any kind of software. So no need to worry about the software. Because when I start SPS, I am giving the guarantee that within 1 hour, so that you will tell, sir, it is so easy. Because really I am telling you, which is the very software, which is very, very simple. When you start tomorrow the Jamovi software, you will say something. But the problem is, when you start your research, you need your domain knowledge, you need your methodology. So there are 2 parts. You know, research is divided into 2 parts. What is the fundamental concept of your domain, and what is the fundamental concept of your methodology. So if you merge these 2 things, so then you can do that. Okay. So today I am starting with the data. This is very important. Yes. So on this data, we divide into 4 parts. From this data, we divide into 4 parts. So what are the 4 parts? One is the D. So this is our main objective of the research. We have data. Any kind of data. Okay. So then definitely as discussed, what is data? Any kind of data. And from this data, we divide into 4 parts. D. So we have to know, what is the meaning of first, what is the meaning of second, what is the meaning of P, and what is the meaning of So first D, when you get data, so that is basically the raw form. Basically the raw form. That is not the corrected form. So we need some D for descriptive analysis. First is the descriptive analysis. That means we need some summarization. So what is the summarization of data? Question is you can ask me. Question is asked me. Question is asked me, you can ask me. So what is the meaning of summarization? Because if I'm telling a very simple story to you. If I ask individually what's your name, what is your qualification, what is the age, what is the location, so you feel bored after some time. Then you are telling, so definitely you tell, please stop. So that means summarization is some meaningful. Summarization means you will not feel bored. Summarization means it will give the relevant answers. That is called summarization. And from summarization we will get a clear picture. The summarization is very important. So this is the first. So definitely when we start our research, we need to summarize. So this when we get summarized, you can say, so your summarization will not get any clear picture. Because we are the layman about statistics. We don't know statistics. Then how will you understand your summarization part? I am for computer science, I am for education, I am for all science, and how will you understand your mean standard deviation? Not possible. So then after summarization, you start with the visualization, which you can visualize graphically. Because if you can visualize anything, you will clear. So these three captures the two things. One is the summarization, one is the visualization. Is it okay or not? Summarization and visualization. So naturally, when you start our research, when you start our data analysis, we have to understand what things are under summarization. What things under summarization? What things under visualization? There are so many things, lot of things. So naturally, after summarization complete, after visualization complete, then this first D is complete. That is called EDA, Explore Data Analysis. Exploring Data Analysis. Okay. So after this D complete, we come to this next. So why this next D? Very interesting. When you collect the data from anywhere, this data is not certain. So we know the data divided into three parts. One is the primary data, one is the secondary data, and one is the experimental data. So those who are from the engineering background, so they are basically based on experimental data. And naturally we are from the social science researchers. We believe in the observed data. So what is observed data? Now observed data basically divides into two parts. One is the primary data, another is the secondary. The problem is, I am telling you, when you deal with the primary data, that is the real problem. Because primary data, changing from time to time. That is based on psychology. This is based on perception of the human being. Okay, so at some point of time, I can say you are good, and at some point of time, I can say you are not good. So that is basically the example of primary data. I am giving a simple example. I am taking the class in BCI engineering college. So someone entered into the class without my permission, without taking any permission of any participants, and asked me, sir, can you tell me how many soaps, large soaps you are using in a month? Actually, you can ask me. So naturally, as a perfect human being, if I am a perfect human being, what's my answer? Please go down. Because without permission, you enter into my class. Because since I am the soft person, okay, when you write I am using 50 lots soaps per month, which is the perfect integrity. So to avoid the person, I am giving answers. So that is the advantage of primary data. So that's why there are so many statistical techniques applied for verifying this primary data or collecting. Is it okay or not? This is very, very important. So we will, free when you collect the secondary data, because that is based on the previous source already given. We have no risk. So that's why when you collect the data, very important, summarization and the visualization. Now come to the second B part, which is the most important for any kind of research, which is called diagnostics. You have to diagnose your collection of data is correct or not. So when you go for the diagnosing, that is the concept of the probability. Concept of probability. Because maximum when you come in the data, that is not the certain. That is you are collecting randomly. Okay. So that's why it is called diagnosis. So under diagnosis is a very, very fast chapter in statistics. It covers probability, it covers distribution, it covers sampling, it covers estimations, it covers testing of hypothesis, it covers ANOVA and so many things. So that is definitely today I will discuss about diagnosis. Now come to the part, this big part. So P is the very important, we are searching for it. In our research we are saying, can you get a model? Can you get any model? Can you get any supervised model? Can you get any unsupervised model? We are thinking about it. Question is why? What is our objective? To predict some model, as if from the model we can predict some future. So that's why the third thing is a prediction. So the problem is, when you go for prediction of a model, so there are so many errors. So what is the main objective of our research? Yeah, how we can minimize our error. So many methodologies are discovered, so many methodologies. Today, you know, it's the machine learning, and you will be astonished. We are in the 2022. We are in the AI, that is artificial intelligence, but we are running only the weak or narrow AI. So there are two steps of AI are left. And in the 2025, generalized AI is coming. And in the 2030, there is the super AI, which is based on consciousness, psychology attached. This is the problem of data analysis. When we are collecting the data, we are ignoring the psychology of the human being. So nowadays, one method is coming. When we are collecting the data, we have to consider the psychology of the human being, the respondents. So that will come super AI. Question is, why this AI is coming? Why we are thinking about the machine learning? The same simple answer is how to get minimized. We are thinking artificial neural data, deep learning, main objective is how to get a correct figure. Question is why? Because we know, everyone will know, there is no concept of optimization. Optimization is a very vague term. Very better term is we are trying to reach to the good optimization. To the good optimization, not the perfect optimization. No, nothing is the perfect optimization. You cannot say as a human being, I am not the fully optimized. There must be. So that is that's why predictive model having something. If we say regression model, there is something. If we say clustering technique, there are something. If we say that means there are some supervised learning, unsupervised learning, reinforcement learning, everywhere. So many methodologies come down very good. Okay. So that's why the last part is developed. Last part is developed because our objective to minimize error. That is what prescriptive analysis. Prescriptive, which is very important. What is prescriptive analysis and near-term? So within this, so you can ask me the question, sir, we are doing 7 days research methodology workshop. So why do the structural equation modeling? So structural equation modeling will not cover, I am telling you, your testing. It will not cover. Structural equation modeling gives you the validation of your prediction. It will not cover the prediction. That is a different thing. So that will under the optimization. So naturally, for the today's class or today and tomorrow's class, I cover these 3 parts. That is the DDP. DDP, not possible to cover this the last 3 parts. Okay. So under D, first we start with the first D. What is first D? Already I told somebody. So you can ask me, why do we need somebody? Why do we need somebody? Because if I say in the class 10 level, any board exam, there are 10 lakh students, and I tell you to go through the 10 lakh students and tell me what is the mathematics marks of 10 lakh students. What is the mathematics marks of 10 lakh students? I cannot give you the problem. Okay, sir, then you tell me, sir, 10 lakh students is a very large population. So naturally, I have no time to solve this problem. And since I am giving my time, I need some money. You have to give some money. So cost is involved. Is it okay or no? So if you go through the complete population individually, so naturally, huge time, huge cost. So automatically, so then you can say, sir, The cost is a function of that. So if we go for the complete enumeration of the population, so we need a huge time. Then since we need a huge time, we involve the huge cost. And when there is a huge cost, automatically profit comes. Because this is the order. Profit comes. So then there are some profits by which you can profit. So then we will come statistics. Then we will come statistics, because statistics without concept of sample. Statistics deals with the data. Statistics is the aggregate results. But that's why we try to ignore the individual. Because from the aggregate results, we can get some idea. And that is called summarization. We have to summarize that. Now, okay, just wait for 5 minutes. There are some formalities left.
No.
Sorry. So are you feeling bored?
Okay, so we will take few minutes to felicitate our guest of honor. So now I request our Honorable Vice Principal Sir, Professor Dr. Hussain, to kindly felicitate our guest of honor, Professor Dr. Gautam. Please, sir. I will also request our Vice Principal Sir to kindly felicitate Professor Dr. Anita Pal. Please. I will also request our Vice Principal Sir to present Professor Dr. Anita Pal with a medal. Please, sir. Thank you so much, sir. Now I will request our dignitaries to kindly take this. And now I will also request Professor Bandopadhyay to continue with the rest of the session.
So let's come to the part. This is the why we study. I think you understand why we need statistics. Very interesting part. The statistics meaning we can break into statistics classes. Can I write? Can I write statistics equal to statistics classes? I hope practical that. So these statistics basically mean data that is signed. I hope it is clear. And what is process? If you tell me, sir, I am taking only one sample, so no stats. So I have to collect more than many samples. So that's why the concept is called, statistics classes that we are collecting before. So next question is why are we collecting? Obviously, question is why you collect. So if we ask you, these are trying to understand, then you can understand what is the nature of data. If I understand, sir, can you tell me how your student Bandopadhyay is present in the class? Dr. Durgapur. So how is Durgapur? You can ask. Then I can say, Bandopadhyay is good. Then you can ask me, sir, how is your Bandopadhyay is very good? Is it clear or not? How is it? Now I know some characteristics of Uru. That's why I am telling Uru. Uru is very good. Then he says, what are the characteristics you are telling? Now I know Uru is a good academic. I know Uru is a good singer. There are so many properties of Uru. Okay. That means from some human being there are some characteristics. Similarly, when you collect the data, there are some characteristics. Is it okay? So definitely you have to judge or consider the characteristics of the data. And these characteristics are aggregated characteristics, not the individual characteristics. We are collecting the characteristics of Dr. Durgapur not for a single day, for a several. Am I wrong or right? Similarly, when we collect the data, we collect the several data to gather some information. So, what are the characteristics of the data? So, Durgapur is a public. Don't mind, I am taking only one. And it is not possible. Is it possible to own for the 50 years, having 50 years data? Is it possible to know all 50 years data? So we have to collect some. So we collect some. So that means you can say sample is a subset of population. Sample is a subset of population. So the characteristics. So what are the characteristics? The first characteristics is for today I am going to directly sample. First characteristic is aggregate characteristics. You calculate that. First but definitely, when the characteristics form only average characteristics, it is not possible to find the full concept of it. So we go for the other characteristics. Question is what? So I am giving a simple example. Say, we collect the observation. This is a sample. These are the sample, 5 observations. So what are the 5 observations? The 20, 30, 40, 50 and 60. Is it visible? 5 observations. Last, clear? Then when we collect these 5 observations, that is n equal to 5, we check that mean equal to 4. That is average. We calculate average. We calculate median also 40. Very good. Mean 40, median 40. Is it okay or not? And if you check, I arrange the observations in increasing order. 20 is the minimum and 60 is the maximum. Is it okay or not? So then another, so you have taken these 5 observations. So I can change the 5 observations like this. 20, 35, 40, 45, 60. Change this 5 observations. Is it okay? Change the 5 observations. So when we change these 5 observations, very interesting, we check again the mean is 40. Again the mean is 40. Not only that, again the median equal. So now we are in the problem. Because in the organization, every time we are thinking which company is the best. For the stock market, which company will be the best? For the students, we are telling for their placement job, okay, you have to go for the job because this company is good. Now we go. We collect some companies data. So there are so many different. Now we can collect some financial. We can collect some your marketing. We can collect some their operational. There are so many levels. And we need some analysis. So we are doing today's class. What is the statistic? Is it okay? Statistical. So the question is, so there are this is the set 1 data. This is called set 1. And this is called set 2. So as a level, I can ask you, can you tell me which two sets are given? So which out of two sets, which is paper? Two sets, out of two sets, which is paper? So definitely paper means a set which gives the minimum error. The set which gives the minimum error. So then you can tell me, sir, how you calculate the error? I know nothing about statistics. Then one thing is like, okay, you know the mean, because mean is very simple. Sum of all observations divided by the number of observations. Then 40 is the mean. Try to understand, very interesting. 40 is the mean. 40 is the mean. Both sides is mean as well. But in the first case, the neighboring observations near to the mean, one is 30 and one is the near to the mean. One is the 30 and one is the 50. So what is the deviation? Minus 10. What is the deviation from the mean? And in the second observation, the deviation is minus 5 and deviation is plus. So automatically, we say that the second set, the deviation is less. Is it okay? Deviation is less. So we go for second set. Now automatically you will answer questions. Sir, today you are taking only 5 observations, but instead of 5, if you take the 5,000 observations, now how can you solve? Obviously, is it possible to manual checking? You are taking only 5 observations, you will check manually. But instead of 5, if you take the 5,000, definitely we need some method to analyze which set of observations are giving the meaning. Am I wrong, right? So then, another characteristics has come to the statistics. That is called standard. That is the second characteristics, second descriptive measures of statistics. Is it okay or not? So today's discussion in the first term, there are so many statistical measures. I am telling you for the summarization part, divided into 2 parts. One is called phone number summary, another is called 5 numbers. So what are the phone number summary? Phone number summary is the first summary is the average. First summary is the average. Second summary is the standard deviation. This is the phone number. Third is the skewness. And fourth one is the courtesy. So since skewness and courtesy, I discussed with you all. So definitely in today's class, you get some idea about everything. That is the mean and standard. The question is, you can ask me the question, why do you concentrate my major part in the mean and standard? If we check the share market, if we check anything which is based on data, we are calculating mean and standard. Because there is a very interesting term that is called average of average. When we solve the time series data, the term basically time series basically based on average of average. Question is why if we go for average of average, we are going to the conversion point, then we can really say. That's a term is called average of average. And since average of average, then there is some error in the first. So today's discussion basically based on mean standard. So you can ask me the question of why. Because when you deal with data, so we can divide, suppose univariate data, bivariate data, and multivariate data. So what is univariate data? Single variate. What is bivariate data? Single variate. What is multivariate? Okay. So when a univariate data, problem is that what is interesting thing, when there is a univariate data, there is no concept of the dependence. Because there is a univariate. When there are bivariate, then the question is, there is some causal relationship. Causal relationship. Maybe out of these two variables, one is dependent, one is independent. So you have to think forward, domain now. And when there is a multivariate, this the problem starts. When there is a multivariate, the problem is, it is the supervised, it is the unsupervised, it is the real flow event. Then the problem starts. So when there is no, so basically it is bivariate. I am telling you today I will discuss, definitely after my first session, I will go to the work, hands-on SPSS. Then you will get some flavor. And second session, after lunch, I will start my bivariate class. That is basically based on, correlation. And I will show you this total correlation relation and totally covariance based on mean. So mean and standard deviation is very, very important. And tomorrow's class, I need some other measures for descriptive characteristics that is called stimulation and catharsis. So now when you know this thing, then I can define what is catharsis. We know this. Now what do we know? We know some characteristics of, we know some population size, we know some sample size, we know some sample characteristics. So what is our objective? How to estimate the population parameter on the basis of sample size? This is our main objective. Again repeat, population is one term, very big term. Parameter, that is second term, which is the characteristic of population. Third term is samples, like data, which is direct. Data, statistically, characteristic of sample. So, these are the basic four terms I am telling you, try to remember. So, always when you get some data, and when you calculate something, you tell this is the population parameter, this is the sample size. Basically, we are collecting sample. So we are calculating sample size. And why we need population parameter? Because we have to estimate the future, which we don't know. We have to estimate something. And that's why the testing of hypothesis chapter. And since we don't know any kind of data, we need some probability. That's what I will discuss. And for the probability class, I will give you a very real or interesting test study. That is because why I am telling you probability is important. Because using, if we know probability, then we can, predict the future. We can predict the future. So there is a very interesting case study of probability that's called basic. Very interesting case study. And I will tell you that case study, I will show you based on this our COVID situation. We have developed this case study, small case study. So easily anyone can understand because this is the very relevant, anyone. So that is another aspect. Now, I am coming to the next point. When you get data,
Sir, I have one doubt.
and you
Sir, this summarization of data could say we can find out which sample has got a better data set by using mean standard deviation.
Initially. But I am telling you, mean and standard deviation are not enough.
No, of course. Now, when we, the problem is not with the secondary data. Problem is basically, my problem is basically with the primary data.
I'm telling you, I come primary and secondary data, scaling data after my first session. Because first session, this session is basically, I have collected data. And now collecting, when you go for the categorical data, non-categorical data, that is another issue. Okay. So this is basically based on scale type of data. I am collecting salaries. Already I am giving one example that is 20, 30, 40, this is scale data. And there are, I am telling you, there are numeric trees. Basically, forget about the term. Forget about the term nominal, forget about the term ordinal, forget about the term scale. Forget about the Melcher scale, forget about the Sustan scale, forget about the Woodman scale. Forget about it. Basically, we understand one thing. If I say, how many telephone calls you are receiving? Not saying you are factual. Am I wrong or not? Okay. So then you get the idea of discrimination. Clear or not? If I say, can you tell me what's your salary? Then I will say, okay, 50,000.55. So that is not the discrimination. If I say, what is your age? You will say, sir, my age is, 30 years, 6 months. So what is the discrimination? So that is basically, when you start any kind of analysis, you think about it, which is the continuous data and which is the discrete data.
Sir, my problem is when I am taking data which is based on psychology of the person. Say suppose I am taking
Go to the questionnaire.
No, already you told like you gave the example of the Lakso.
Yeah.
It is bound to be biased.
Yeah.
So if it is bound to be biased, the skewness, kurtosis, everything has to be, it's very hard to bring it to a normal distribution.
I'm telling you. Suppose I'm the student of statistics. Now how do you know what is normal distribution? Because normal distribution chapter will come in any book of statistics in the second volume. If we go through the fundamental statistics by Durgapur, so in the first 4, 5 chapters, 6 chapters, no concept of normal distribution. So definitely on the data one by one will come. Now the concept of why the normal distribution falling and why it is needed for data. That is the main thing. There are 100 distributions in statistics minimum. Now why we are taking every time the name is normal? Definitely there are some meanings. So I will prove you why the normal name is coming. No need to think about it. Automatically it will come. Question is why? Then I will discuss about the 5-point summary. Give me some time. Okay. So now I am coming to the very, very important part. Let's call 5-point summary. This is very important. So when you get data, so what are the 5 points? Suppose you have a data set. You have a data set. You know the data set. From data set, you know the minimum value. You know the Q1, 25% of the item, first quarter. You know the second quarter. You know the third quarter. And you know the. So that's why it's called 5-point summary. So question is why this 5-point summary is important in statistics. So since I am the student of also mathematics, so in mathematics also there are 5 points. These are called fundamental number in statistics. Fundamental number in statistics. So similarly in mathematics also, fundamental numbers in statistics. So what are the 5 fundamental numbers in mathematics? Then you can relate. One is 0, one is 1, one is 3, one is I. You can write. These are the 5 fundamental numbers in mathematics. So you can ask me the question, why? The basic thing is, there is a concept used called Removier theorem. Just to think 5 numbers are important. There is a relation. I am not going in detail. This is a cos pi plus I sin pi. It is a simple way. So 5 points. E I pi 1. That's why these are called 5 fundamental numbers. Question is why? Because without 0, 1, no spaces, no R, no Python, no computer, no internet. Without I, no mathematics, no complex number. Without complex number, no analysis, no time series. Time series is totally based on computer. high complex. Real number is a subset of all. So that is I is the fundamental. E without E, nothing in step shop. Nothing in campus. And naturally, you know the why logic. So that's why these are called five fundamental. Five fundamental numbers. Is it okay or not? So now, but today's discussion basically based on 5 points summary. There is a when you get data. So naturally, when you put data in software, simply click we get. Why when you get the data, simply click we get mean standard. That is not a problem. Our problem is after getting the result, how to apply. Clear? 5 point summary. Then now what problem we face? I am giving you an answer. Problem we face. We are collecting the data. These 5. Very interesting. Right? Now when you collect this 5 data, 2, 4, 6, 8, 10. And you check that, and the mean is 6. Mean is 6. And not only 6, the 2 observations belonging and 2 observations above me. Am I wrong or right? Not only that, the deviation from 6, 4, that is minus 2, there it is plus 2. And the deviation is minus 4, and this is plus 2. So with respect to the mean, all are equally deviated. In the right hand side, also in the left hand side. Is it okay or not? So now, we want to plot these. So that is, 6, this is 4, this is 2, this is 8, this is 10. You can easily plot. And this is the mean. 2 observation belonging, 2 observation out. So now suddenly, because this is the nature of data, data is random, so we take the another observation 60. But the problem will face. Because the data is random. Another observation we have taken 60. And when you consider 60, so automatically the mean is changed. So what is the mean? The 30 plus 60 divided by 6, and that is equal to 50. Very surprising. So try to plot the data set. So we plot 50. So what is the nature of the graph? The 5 observations below 50 and only 1 observation above 50. Am I right? So 5 observations below 15 and 1 observation above 15. So maximum observation below mean. So what conclusion? That means this 60 is not the usual observation. This 60 is the unusual. And that's why it is called outlier. And when you can remove outlier, if you can remove outlier, so then it is some pattern. And this type of pattern, definitely, when you get some pattern, there is a name. There is some name. And maximum we are thinking about the symmetric pattern. Symmetric pattern. And from the symmetric pattern, you see, when you get this data set, that is called symmetric pattern. Why symmetric pattern? Below means 2 observations, and 2 observations have a symmetric pattern. And that's why it is called co-distribution. Maximum when you thinking about it. I'm telling you a very interesting example because we are all the faculties. In the class, there are 100 students. And out of 100 students, if you check their marks distribution, there are some average ones. Some students below average, some students above. And if you draw the graph of the mass distribution, if there is a symmetric pattern, you say, okay, this is the normal pattern. 50% students belonging, 50% students out. So then you can say, okay, we can say this is a homogeneous set of data. If we check that, more than average, 90%. Say, well, it's not the symmetric distribution, the class performance is very fantastic. Fantastic, this is a positive distributed. So definitely, when you get, that's why you need the visualization. Now, so today if I get time, I will show you some real case studies on outlier, because when you get some data, I'm telling you, get some data, first you move for is the data summary. So what is data summary? Divided into what? What is the 4-point summary? And that is the step. What is the 4-point? The mean, standard deviation, steepness and curve. What are the 5-point summary? Minimum, Q1, Q2, Q3. And from this descriptive part, you form your research, you go for analysis, discussion. So what is the meaning of this? What is the meaning of this? That is from your domain. That is from domain. Is it okay? So I am thinking about only the univariate. So now we are coming to the part, is there any outlier? Is there any outlier? How we check it? So there are so many methods for outlier. So you can ask me the question, this is why we divide into 2 parts of descriptive measures. You are saying the 4-point summary, you are saying the 5-point summary. Question is why? Because when you check the outlier, this is divided into 2 parts. One is called the parametric outlier, another is called non-parametric. So for the parametric outlier, we will consider the mean standard deviation. And for the, also I am telling you, for the parametric outlier, we are considering mean, standard deviation, skewness, and bias. So these are basically for parametric outlier. And for the non-parametric outlier, I will discuss later on. We will consider this Q1, Q2. So there are 2 parts. When you get some data, is it your parametric data? Is it your data? So I am telling you, this total data analysis, it's a sequential process. Don't jump. It's my request. Don't jump. So first you go for parametric analysis in detail, then you go for non-parametric. Okay, but I know most of the meetings, because parametric analysis will takes at least 5 to 6 days to learn as a research workshop, and for the non-parametric also at least 5 days. Because non-parametric is a very hard. But if you ask me, sir, can you give some non-parametric guidance? It's not possible. I can give that because there are at least 15 cases for the non-parametric. Minimum 15 cases. Which one is that? You are doing for analysis, first of all you have to check that your data is the parametric or non-parametric or not. And if it is not parametric, you have to prove it that my data is not parametric. And then definitely which methodology used for non-parametric you have to check. Because non-parametric there are so many methods, independent sample, repeated sample, more than 2 independent, more than multi-independent. There are so many other differences. So many things. How to decide it? Again, I'm telling you, if you start from the basic now, then you can definitely, there will be some point you understand. Suppose you are using t-test. I'm giving a simple example. You are using t-test. What t-test? Assumptions. So then you have to think of it, okay, since my assumption fell, definitely there are some other methodologies you have to use. Suppose you are doing some ANOVA. Suppose your assumption fell. Because for any kind of statistical method, you need to follow some assumptions. Question is why the assumptions are important? Because it is based on some. You have to, assumption means you have to follow some method. There is main assumption is no outlier. There is no assumption is error. The data set error must be the homogeneous. That part I will discuss. your problem is, since you are in some, say, some point of research point, what methodology you use, that is a very, very but my perception I am telling you, if we know that two things, when I start second session, if we know the concept of relation and covariance and relation, then you are actually.
The problem is not like what we face is whether we should go with the parametric or non-parametric. Which one is more better?
When you get the number, which is not more authentic, that is depending on your pattern. First you calculate the first file, for summary calculation, and plot in the graph. Simple, plot in the graph. And there are so many graphs, that's what I am showing you. And from the graph, you can understand what is the concentration of the data. And main problem we face, if there are a lot of outliers, again I am repeating, if there are a lot of outliers in your data set, then parametric fail. So you have to check how many outliers present in your data. Is it okay?
Checking of normality.
Checking of normality is different. Checking of normality is different thing, outlier checking is different. So I am giving a simple example how we check this outlier, and you can understand. And understand your question. I am giving a simple example. Say you have 100 students. Then you can understand this around outlier. And x bar equal to 70. Okay? Clear? And standard deviation, say 5. Can we say and n equal to 100? Only this information I have supplied. Nothing else, no data set. Can you say is there any outlier? Anyone? But don't mind, I am not asking the question. This is the discussion. Just discussion, interact. This information I have supplied as a research person. There are 100 observations, the sample being 70, and standard deviation. That's it. My question is clear. First of all, you tell me question is clear. Very interesting question. Then you get your answer. Then what will you do? Because I have got this information from my data set. I have data set. And only I have collected the information, there's the descriptive information that 100 sample, mean equal to 70 and standard deviation 5. Then question is, can you tell me with the help of statistics, that with how many outliers? Then what is step 1? Step 1 is first we assume that my data set is normal. First we assume that my data set is normal distribution. Now when we assume this data set normal distribution, so we have to know now what are the properties of normal distribution. So number one is normal distribution is the symmetry. Normal distribution is the symmetry. That is the above mean and below mean the same number of occurrences. This is the number one. Number two is what is that? It represents Bell distribution. Quantum, Bell distribution. What is the number three property? Mean, median, mode, assess. E. Number three property. Number four property, stimulus equal to zero. Number fifth property, curvature is equal to zero. Now, when you tell about the property, very interesting term. When you tell about the property, basically is a theoretical property. So when you try to prove, this theoretical property with my sample observations, not exactly. My question is clear. I am saying about the theoretical property. Theoretical property means which is based on the population. But we are trying to establish with my sample. And sample is very small. And definitely the theoretical property is not exactly satisfied by the sample size. So we try to near this. So mean and median more or less the skewness tends to 0, not equal to 0. The cardinality tends to 3, not exactly 3. Is it okay or not? So then we can say my data set is the no. And this is called the theoretical statistical concept. And if you check the distribution pattern, there are so many graphical features. That's what I will show you when I solve the software. Graphically. So there are a lot of data. And graphically, okay, this is not. Okay, this is not. Graphically, within a second, you take the decision. So now I'm coming to this point. What is the very interesting point? So we draw the normal distribution. Okay? And this is X bar. This is S, standard emission. This is also. Here, this is 2S. This is also 2S. This is 3S. This is 3S. Is it okay or not? So now,
Sir, I have a question. Sir, do you mean it's H bar plus S this side and H bar minus S?
yes. Because there is a one sigma level. But actually, S are the positive. S standard deviation can never be negative. So that is X bar plus S and X bar minus S. Easily we can compute. Am I wrong or right? Clear? So this is the area. This is the area. So theoretically, what is the concept? At least 69% of the observation lie between one sigma. That is lies between X bar minus S and X bar plus. That is the theoretical. Now I have to check with my sample. Is it okay? With my sample. And one sample if we check, that is say 84 observations lie between. So how many observations below this? Some observation below this, some observation above this. So that is considered as the outlier if we use the 1 sigma. I am telling you, when you start your research, if your sample size is very big, huge sample size, so you have to discard some elements because some outliers present. So you go for, and you check already, that is normal distribution. Already check. Then you go for 1 sigma because your sample size is very huge. If your sample size is moderate, then you go for 2 sigma. Because naturally acceptance level is high. Is it okay or not? And if your sample size is very small, really problem faced in the share market analysis, then you go for 3 sigma. Is it okay or not? Now question is, already you told me that this is the concept of parametric analysis. Now what problem will you face in the non-parametric? Because non-parametric means no normal distribution. Why non-parametric occurs? There are huge outcomes. And that's why, in case of non-parametric analysis, we apply median, not mean. And for median having no distribution, that's what I discussed. Mean having distribution. Okay. Now, is it clear? Sure. Now come to the part next one. Next part is, say your data set is not proper. Already you find. Not proper. Then how you find the outliers? We need the 5 points. So you know Q1. You know Q1, that is the first quadrant. First quadrant. Plus and Q3 plus so this is called lower level and this is called upper. This is called lower limit, this is called upper. So let's say we have data. From the data easily you can compute
তো হ্যাঁ দেখেছি তো আপনি তাহলে ওখানে স্যারকে ব্রেক দিতে বলুন মানে থামতে বলতে 2 মিনিট পরে দিয়ে আপনি যখন ব্রেক থামবেন তখন আমার শুরু
So we get some value, say A and B. Okay, that's sorry, just we get A, we get some value. So now this is your data set. This is your data set. You check, say that you have say 100 observation. So observation 1 lies between A and B. Yes or no? If it is yes, no outlier. If it is no. So in this way, we can check how many outliers present my data set. Because if we don't remove the outlier, it is not very good. Now you can ask me the question. Yes, sir, if we remove the outlier, this is the real question. If we remove the outlier and if we get a model, how we can use the model for by the real world? Because in the real world, it deals with the outlier. Your share market deals with the outlier. The answer is, that's why it is very much difficult to predict the share market. Very much difficult. And that's why this type of AI, machine learning, these are different methods are coming. Yeah, how we get a robust model. This is the reason for that. There are so many methodologies coming. But I am telling you, since there are so many computer faculties are there, when you apply machine learning, ANN, deep learning, that is basically based on 5 parameters. Basically, ANN, deep learning, and anything else, reinforcement learning, basically based on 5 parameters. So what are the 5 parameters? First parameter is we have to know statistics. I am saying parameters. Second parameter is the linear algebra. Third parameter is you have to know probability. Fourth parameter is you have to know calculus. And fifth parameter is option. So any kind of machine learning, deep learning, ANN basically based on this. So if we know this by and actually the statistics is the ocean. Linear algebra is the ocean. Is it possible to know statistics? Impossible. This is possible to know linear algebra. So what we can do that? So for my research, which things are needed, that only we can learn. So for my research, I need only, say, structural diffusion. So naturally, we have to know. So if we want to know structural diffusion modeling, so before that, there is the sequential process. So before structural, what do we have to know? So that's the sequence. That we have to maintain that project. Suppose if you say, sir, my research based on gain and neighbor. So okay, gain and neighbor. So for the gain and neighbor, what are the basic parts? Sequential. So for the my research is the support vector machine has been. Okay, support vector machine. You know this. So this now if you ask me, sir, you know this. You know, I know a little bit. Question is why? And I am telling a very interesting part, since we are all the faculty. Basically, I believe in one formula, This really, I am believing this formula for my research, for taking the class. Because if we believe this formula, automatically your research will be done. Your class performance, my pedagogy will change. Or pedagogy will change. What is that? It's a P form. For taking any research or for taking any class, the main thing is the perseverance. If you have no perseverance, it is really difficult to perform. And if you have the perseverance, then you go for the practice. practice. So naturally question you can ask how many times? My answer is 10 times. It is depending on you. For my case, because I am not at all a good student, that's why I am practicing 5 times reading. But you can minimize it according to your level of efficiency. And if you go for practice number of times, so automatically your perfection I'm giving a guarantee. Is it okay or not? So that belief in one formula. Another formula I believe before starting my second session. Another formula I believe that is the 3 word of this formula I believe. Question is why? When I start anything, suppose I have to know regulation. So first I will tell what is. Second I will tell why we need regulation. And then last part how we use software. Because software basically do. Is it okay or not? So thank you. Please wait. Already, sorry. Okay. So next up, I will start SPSS. Are you feeling bored?
Okay, so let's take a short tea break and we will back by 12:20 p.m. Some refreshments are arranged in the downstairs and drinking water is available in the upstairs. Okay, so we will back by 12:20 p.m.
না তোর এসেছিল কি ইয়ে অভিযোগ করতে
মানে আমি নিয়ম বলছি এখন যারা দূরে আছেন তারা একটু কথা শুনতে অসুবিধা হচ্ছে আমি বুঝতে পারছি এর কিন্তু এই সিস্টেমটা এমন একটা কথা মিস হলে না আপনাদের ভালো লাগবে না এই জন্য যদি একটা দেশে জীবন সফটওয়্যারটা আমি কি বোঝাতে পারলাম একটা ইন্ডিভিজুয়াল মেশিনে কিন্তু সফটওয়্যারটা নেই মোটামুটি এই সেশন থেকে আবার মোটামুটি কটা মেশিনে পড়েছি সামনে কোথায় এবার 12টা মেশিনে হয়েছে এবং তারপরে আমি তো আর একটু চেষ্টা করলে একটু বেশি হবে কিন্তু সবাই ফিজিক্যাল মেশিনে তো হবে না এই জন্য আপনারা যদি একটুখানি শেয়ার করে দেন মেশিনে না বুঝতে পারেন
হ্যাঁ আসছে আমিও আসছি তো আমিও তোর সাথে কথা হলো কি
আমি দেখলাম
সুভাষিস আমি অমিয়কে একবার ফোন করেছি আবার আরেকবার ওকে ফোন করতে হবে তাহলে ওকে একজন হেল্প করে দিলে ও তাড়াতাড়ি করে ফেলতে পারবে ওই যে অমিয়কে একবার ডেকে দিতে ইয়ের কাছে শাওনের কাছে আমি একবার করেছি আরেকবার করলে না রিইটারেট হবে
আপনাদের বেশি হয়ে গেছে
আচ্ছা গৌতম না এখন থিওরিটিক্যালটা করে পরে সেশনে কি প্র্যাকটিক্যাল করাবে
তাহলে কি লাঞ্চের পরে সেশনটা করব
হ্যাঁ স্যার সেটাই ভালো হবে
লাঞ্চের পরে সেশনটা করি তাহলে এবার একটু মাইন্ডটা অ্যাডজাস্ট করতে হবে
ওটাই বেটার স্যার
ওইটাই বেটার তাহলে লাঞ্চ আমি তাহলে এই সেশন থিওরি নিলে অসুবিধা নেই তো
না না
ওই থিওরি পড়া
আচ্ছা ইয়ে ফোন করলো কি সুভাষিসটা ফোন করতে বললাম যে
সেকেন্ড ধাপে আমরা করবো
আচ্ছা আচ্ছা
বলছি অমিও সাথে থাকলে তো হয়ে যাবে
মানে পেন ড্রাইভটা লাগবে
বেশি করতে হবে না
এটা কোনটা দেখো এটা এখানে সবাই হচ্ছে ঠিক আছে স্যার মোটামুটি এই পার্টটা তো করছে না ইউনিট পার্টটা ততক্ষণ হয়ে যাবে
লাস্টে যারা আছেন কিছু যদি মনে না করেন আপনারা একটু আগে আসতে পারবেন একদম
কি নিতে হবে
হ্যাঁ আমি বলছি খুব সুবিধা হবে
কোন ফোল্ডারটা
চেয়ার নিয়ে আসতে হবে মনে হয় মনে হচ্ছে যদি চেয়ার থাকে ঠিক আছে
Welcome back, everyone. Kindly take your seats, and we should be continuing with the session.
তাহলে স্টার্ট করতে বলে দিলেন না? ও বলে দিয়েছে মাঝখানে।
Hey, Sayo, can I start now? আমি একটা জিনিস বলবো, পিছনে যারা বসে আছে এই সেশনটা তো হ্যান্ডস অন হচ্ছে না, আপনারা একটু সামনে চলে আসুন। এখানে অনেক চেয়ার আছে, চেয়ারে এখানে বসে যান, তাহলে দেখবেন শুনতে পারবেন। ডোন্ট মাইন্ড।
আর না হলে ইনস্টল করছে না দিয়ে তো ভাগ না।
আচ্ছা থাকুন না, ইনস্টল
হ্যাঁ
Sayo, আমাকে একটু বলে দিন। ও আচ্ছা, সায়ন পেয়েছি। হ্যালো, শোনা যাচ্ছে? Can I start now? My voice is audible to all of you? Yes, sir. Yeah. Now, for the today's session, this session I will discuss about Iberian. Univariate means already I told you single variable. So, first of all, what is bivariate? Say, better we start with a simple example. The demand of cold drinks, very basic example, and temperature. Simple example. So, what is the meaning? If temperature increases, demand of cold drinks increases. Temperature decreases, demand of cold drinks decreases. Another example we can take the demand of wooden goods. So automatically, if the temperature increases, demand will decrease. Very simple example. So we consider two variables. So from the domain, we have to think of it. Which one is the dependent and which one is the So obviously, temperature is the independent variable and demand of cold drinks is the dependent variable. Is it okay or no?
Yes.
This is very important part. So that is, we consider demand of cold drinks dependent means Y and temperature is X. Now, the very important term I am using. Since X and Y are two variables, this is called random variable. This is called random variable. The question is, why it is random variable? Because it takes the several values with the different probabilities. So why it is random variable? There is a very interesting story. Suppose I have collected the data, all are true. Is it possible? All observations are same. Now what problem we will face? If all values are same, the mean equal to 2 and standard deviation equal to 0. Now when the standard deviation equal to 0, so definitely the data set is not random. So when you get any kind of data, just you simply you calculate the mean and standard. Simple. Okay. So this is the first observation. And that's why we call it is a random. Now, hello. So I'm taking simple example. X is a random variable and Y is a random variable. That means X takes some value and Y takes some value. X is a univariate, Y also univariate. Now we are trying to join both the variables. This X takes the value, say 2, 4, 6, 8, 10. What problem we will face, I am telling you. And Y takes the value 3, 5, 7, 9, 11. Is it okay? So X is a variable, again repeat, takes the only 5 observations. And Y is a variable, takes the 5 observations. And from these observations, easily we can compute X bar. From these observations, easily we can compute Y bar. So X bar equal to 6, Y bar equal to 6. I hope it is okay. So descriptive part is complete. So now we go for visualization, which is the most important. So what is visualization? Visualization part is that two variables x-axis and y. So this is the x-axis and this is the y. Clear? So along x-axis we plot the points 2, 4, 6, 8. And along y-axis we plot the points 3, 5, 7, 9, 11. We plot them. So now this 6 is the x bar. Seven is the y. Clear? And this is called origin 0, 0. Okay. So that is, it is called, in class 9, 10, 11, this is called XY plane. So what is the meaning of XY plane? Now there is x-axis. Yes. And what is the meaning of plane? That means it contains some points along x-axis. It contains some point along y-axis. In statistics is also. Okay. Now, up to this okay or not? Now from this x bar, we draw a vertical line. We draw a vertical line. And from y bar, we draw a horizontal line. Is it okay? So this is the term is called perception matrix. This is called perception matrix. How we can perceive our data? How we can perceive our bivalent? How we can perceive when we look at multivariate? That part is okay. So that is the first quadrant. That is the second quadrant. That is the third quadrant. And that is the fourth. So what is the meaning of first quadrant? All are plus plus. Note. What is the meaning of second quadrant? Minus plus. What is the meaning of third quadrant? Minus minus. And this is plus plus. Is it okay or not? So what is the meaning of this plus? This means xi minus x bar greater than 0. That's why it's called plus. Xi is the observation. Just to check, 8 is greater than 6. 10 is greater than 6. That's why xi minus x bar greater than 0. Similarly, yi minus y bar greater than 0. That's why it's called plus. So what is yi? 9, 11 greater than 7. Is it okay or not? Now come to this part. Minus. Minus means xi and yi. Clear? What is the meaning of third quadrant? Xi, yi, all are negative. And what is the fourth quadrant? Xi and yi. Is it okay? So when you get this condition, that is very interesting. From the class 7 level, we know if we multiply plus into plus, that's plus. If we multiply minus into plus, that's plus. If we multiply greater than into greater than, that's plus. Everyone knows. Same thing we are applying. So this is the plus into plus plus, that is called positive. Positive. Minus into plus, that is the negative. Minus into minus, that is positive. And plus into minus. Is it okay? So now, so initially we start with xy plane. Initially we start with xy plane. So what is xy plane? Now there are some x-axis, and there is some y-axis, and there are some origin, which is 0. That is xy plane. But we are trying to transform, better to say transform, this x plane to x minus x bar plane, y to y minus. This is a transformation. It is nothing but transformation. Question is why we calculate x bar from the data set. We calculate y bar from the data set. And we are creating a new center. This is called new center, new origin. This new origin is x bar. So instead of 0, 0, we are considering this is a new center, transforming the center. X bar. Is it okay or not? Transforming the center. And when you transform the center and taking the product of this, xi minus x bar into y bar minus 1. X is replaced by xi minus x bar. Y is replaced by y minus 1. And we know x-axis contains several points, y-axis contains several points. So naturally, how to relate with this summation? Take a summation. Is it okay? Summation. Sum of all these points. And what is our objective? So our objective is to get a measure. Measure. Why we need measure? Because measure of association. Because our objective to measure the association between x and y. So what type of association? Maybe positive association, maybe negative association, maybe no association. Is it okay or not? Maybe positive association, negative association, and no association. Now how can we make it? So obviously, if this summation is greater than 0, definitely it is a positive association. And if sum is this is the less than 0, negative association. And it is equal to 0, no. So that is very important transformation. And not only that, in transformation, we need only the mean x bar. So that is the application of mean. We are applying mean from univariate to bivariate. invariant by that, only for doing some transformation. Now, then statistician and mathematician tell, okay, you are taking summation, but it gives a very huge value. But we need only the aggregate results. So we need average. We need average. So you divide, because we divide by number of observations. I am writing n by n minus 1, definitive experiment. I am writing n by, we are replacing n by n minus 1. This part I am explaining. So when you get this is a measure, 1 by n minus 1, that is the number of observations, taking the summation, and this is nothing but covariance between x. So covariance between xy is the association between x and y, which is nothing but a transformation from xy plane to x minus x bar into y minus 1. That is the definition. And that's why this is the formula of curve of xy. And when you apply this formula, we get some value positive. When you get positive, that means there are positive associations. When you get some negative, there is a negative association. If it is 0, but the problem starts for the data analyst. So data analyst is told, you are taking the value of, telling that you are taking the value of x and y. Maybe these are very big values. I don't know. Maybe very small value. So then that means x, any value you can take, lies between minus infinity plus infinity. Y also lies between minus infinity. Any value. And when you take any value, this is the problem starts. Then we get this power of xi value is very large. Maybe when you calculate the power of xy for a large data set of any share market data, if you calculate it takes a, the power of xy will come in lakhs, in crores. And from that result, how you interpret? So interpretation is very difficult for power of xy. Question is why? Because what is our objective? How to get the association, the degree of association. The term is not association, degree of association. I am saying, Arun, I am good. Hello, Arun. So Arun can understand this is the positive association. Arun asks one day, sir, what type of positive association? It is a very good association. It is the good association. It is the average association. It is the low association. So definitely the association, this is called the degree of association. Is it okay or not? So from this result, you know, the degree of association is not clear. This is the real problem. This is the real problem of standardization. Me. This is the one problem of covariance. Another problem is, suppose from your data set, x one variable and y also another variable. Say x is, suppose x is, your x is height and y is weight. So obviously we know the height is centimeter and weight is pound per kg. We know. That means the two variables having the different units. Is it okay? Different units. So when you compute this power values, so definitely these units in centimeter into natural product of this. So what is the best thing? So it is not a dimensionless. It is not that error free. It's a real debate. Because when you deal with the data, you need some measure which you can understand it is basically dimensionless or the unique. It is easily interpreted. Is it okay? This is the one problem we face. And so what is the problem? First problem is, what is the degree of association you don't understand? Second problem is it is not unique. Is it okay or not? So naturally to remove this. So for removing this problem, we need some basic factors.
Sir, why we have drawn the quadrants? Because these quadrants mostly looks like the confusion matrix. Does it have any relation?
Confusion matrix, it is coming from the hypothesis part.
Ah.
And this is the field of hypothesis. I am telling about only the deterministic value. So when you start the confusion matrix, that becomes denotes the hypothesis. Okay, so hypothesis means there is some relation between observed and expected. That is what that is. So now come to the point. So x is the variable and y is the variable. So easily you can calculate standard deviation. Am I wrong, right? Easily you can calculate standard deviation. And always you write, it's my request to all of you, no need to remember any formula of statistics. No need to remember any formula of statistics that is given in any textbook, any rules. But it's my request to all of you, only remember the standard deviation. Because standard deviation is everywhere. Okay. So what is the Sx? That is 1 by n minus 1. Please remember this. Summation of xi. This is only that is the standard. Why it is n minus 1? Definitely I will explain. Only remember this. And you remember naturally it is Sx. Sx means standard deviation of x. And what is Sy? The same thing. That is n minus 1. That is yi minus 1. Okay. Naturally, if the number of observations are different, you can replace n1 as that is another thing. So always the number of observations minus. Okay. So we get standard deviation. Now x is the variable, y is the variable, x bar, y bar, Sx and Sy. So there is a term called variance, that is called Ss square x. But we are using the term standard deviation because variance is a square, standard deviation is a square root. And that means the mean of, unit of mean and standard deviation are same. And that's why maximum case we are using the term called standard deviation. Because units are same. So if the x bar unit is centimeter, y bar unit is centimeter, suppose, say pound, then Sx also centimeter. Is it okay or not? Okay, this is simple. Okay. Now, we, using Sx and Sy, we transform this formula. Basically, this is the form of x1. We transform the formula form of xy, divide by because Sx into x1. Simply divide by Sx only to make it unique. Simply divide. And when you divide by Sx into Sy, we get one measure, which is very much well-known thing discovered by Pearson as the correlation. A correlation is called. So that means correlation basically based on covariance. And covariance based on mean. But correlation based on covariance as well as standard deviation. So that is called R of x. Okay. So, very good. So try to understand what is the advantage of this. What is the advantage of this? When you study covariance of x1, that lies between minus infinity to plus. Very large. I don't know. Another thing, it is not unique. Already I told you. But advantage of RxY is lies between minus 1. Is that right? Very narrow, small range. Small range we have specified. And not only that, for R of xy, it is the unique. Now what problem we face? When you get some value of R, so obviously we have to interpret. So for the interpretation, the value of R divided into 7 parts. Now how can we make it? Now the value of R, this is the line, and this is the minus 1 and plus. Is it okay to all of you? Minus 1 to plus 1. My voice is audible last. And this is minus comma makes it because x takes the value any value. That means x takes the value and y takes the value any negative value. Similarly, y also takes the any negative positive value. So obviously, when you get some value of measure, it takes any negative positive value. So that's why comma makes it takes the large value. Okay. And naturally, from the large value problem is we don't know what is the degree of association. Because degree of association is the most important. Degree of association. And that's why, and not only that, it is not unit free. Comma makes it. So to make it unit free, we calculate the standard deviation of x as well as standard deviation of y. And we divide, comma xy by sx. So we get this measure that is called Rx. And there are so many, I am not showing the proof because it is not the class. So there are so many proofs, Cauchy's inequality. We can easily prove that Rxy lies between minus 1 to plus 1. And from this minus 1 to plus 1, we draw this image. Then, because our objective is interpretation. Now, how we make it interpreted? Now we draw a line. And put 0, because 0 is the in between minus 1 to plus 1. Is it okay? So this is my negative side, and this is my positive side. For the negative side, you put minus 0.5, and this is called 0. 50%. I am giving you our grading system. So 50% pass, 60% grade C or D, 6% so grading system. Okay. So we divide this line into 7. 7 parts is very important. Suppose R equal to minus. We are solving some problem. Then we are getting R equal to minus. So what's the interpretation?
Both the variables.
Definitely, R is the bivariate basis. Bivariate basis, so you put the value and put the value of xy, you go to SPSS and put the correlation, and definitely get that. And you get the value minus. So you are surprised. So definitely for your research, you have to write the interpretation. So when you get R equal to minus 1, the problem is, it is called perfectly negative correlation. And I am telling you, if you get this value for your research, it's my request to all of you, please stop your research. Please, if you get R equal to minus 1 or R equal to plus 1 for your research purpose, you just stop your research and you try to modify your exam. So obviously you ask the question why. The answer is very interesting. Because since we are dealing with the sum function, so any kind of measure can never be the 0. Can never be 0. They can never be perfect. It tends to perfect. But if we get R equal to minus 1, that means perfectly negative correlation. So what is perfectly negative correlation? Now if x increases 100%, y decreases 100%. Is it okay? But can you get in any real data this time? No perfect. So definitely if you get any kind of result, so that is called the biasness of the research. So you collected the sample which is not unbiased. So you have to check the biasness. So this is very important. Suppose if you are solving logistic regression, you are solving the support vector machine, you are solving any kind of time series analysis. If you get R square equal to 1, you are highly satisfied. 100% explained. My analysis is very good. Because this is your bias data. Immediately stop. Or try to go. So this is the number 1. So number some part, it lies between -1 to 0. Some results lies between -1 to -0.5. So this is called highly negative. Highly negative. That is a relationship between x1 and y is the highly negative. When x increases, but y decreases not 100%, but decreases. Highly negative. If some value you get -0.5 to 0, in between this is called moderately negative. MNC. Moderately negative. If we get some value 0, maybe we get some r equal to 0. That means ZC, that is 0. No association. Initially I am telling association, later on that is called linear association. That's what I am discussing. If any value lies between 0 to 0.5, that is called moderately positive. Is it okay? If any value lies between 0.5 to 1, that is called highly positive. And definitely if any value equal to r equal to +1, that is called perfectly positive. So I am telling you, in case of reliability, when you start tomorrow's class, based on correlation. When I start with the concept of factor analysis, based on correlation. If I get time, definitely the concept of structural illusion work, totally based on correlation. So correlation is very, very important. And what is the importance of correlation? And I'm telling you, there is one problem of correlation, that part we will discuss in case of factor analysis. There is the one demerit of correlation. And another demerit of correlation is the machine learning. Machine learning. Machine learning will not deal with the correlation. That is the real problem. That's what I definition I will discuss. Now, first of all, you tell me after this okay or not, then I go to the rest. So already we told this association is a linear. That is, I am taking one example. Say x plus y equal to 100. Can I just take this? This is a linear association between two variables. And without using software, we can say that for these examples r equal to 100. No need of software. Question is why? Because y equal to 100 minus x. Here. And if we take x, there are several values of x. If we take several values of y. And if we take x equal to 1, y 98, or 90. If we take x2, 98. And so on, if we take 100, y 0. So try to understand, we are taking x 1 unit changing. We are changing x by 1 unit, increasing, and y at the same proportion decreasing. And that's why it is a negative. Perfectly.
The same x minus y is equal to 0.
Yeah, yeah. X1 is definitely x minus y equal to 0 passing into the round. That is the same value. Passing into the round, that part I will discuss. Is it okay or not? Another thing I am telling you. Say, suppose you get r equal to 0.6 from your results research, then what you will get? Say, using SPSS, this is the most important part. You get r equal to 0.6. Then what you will get? First of all, number one, it is the positive potential. P. R equal to 0.6? 0.61. Automatically I will tell, okay, so these are equal to 0.6 is initially you have the data set. And put the data set in the software, either in Excel, any software. And you calculate correlation and you get this 0.6. Now your interpretation starts. And definitely this interpretation must satisfy your domain. You can read, this interpretation must satisfy your domain. So what is your domain? Well, in the research, you have taken some hypothesis and must satisfy your hypothesis. And if it is r equal to 0.6, so automatically you will say that is a highly positive prediction. Available, right? And if we make it square, that is 0.36. Clear or no? So there are two terms in statistics. There are two terms in statistics. One is the explain part. How much we can explain and how much we can not. So which we can explain, that is error free. That is explained. We know this. And which is unexplained, that is error free. So if we R square, if we explain, how much explain? Only 36% explain. And how much unexplained? 64%. Because we know the probability of success plus probability of failure is equal to 1. So we can think of our explained part is related to the success and unexplained part related to the failure. So that is the most important part is R square. So what is the problem of R square? Most of the researchers, most of the journals, so they are saying, okay, it is not enough, so you have to modify your results. Why? Because R square, our correlation, is basically a static basis. So what is called static basis? Static method means from these R square, so if I write the formula of R square, you don't have any idea about the sample size and about the number of independent variables. Number of independent. So that's why there is one term is developed that is called adjusted. Adjusted. Is it okay? Adjusted. So I'm telling you, adjusted answer. Adjusted answer, that's what I will discuss later on. Adjusted answer. It's very, very important. So what is R square? Again repeat how much we can explain. Then you can tell how much explain means. Suppose we are getting exam. What is the object? We get some value of x, some value of y. Then our objective is get R square. Then we can say 36%. 64% unexplained. Then you can tell these are only these analyses used in my research. Is there any other further thing? No, further thing you can do this. For prediction purpose, you can, since there are two variables, you can write a linear equation y equal to x. Linear equation. So then you can student says, so okay sir, try to understand. Okay sir, linear equation you have written a y equal to a plus b. So by any statistical method, you can easily solve it. And we can solve the value of a equal to the 3, b equal to the 0.5x. And then we can predict what. So try to understand, if your R square is not good, then how can we expect that your predicting model will give you a good result? So definitely the R square will take it very, very important. And most of the cases you will face the problem. Sometimes when you go for any kind of presentation, you will face a problem. Say your R square, really problem, R square equal to say 0.80. You are excited. Really you are excited. That my R square is very good, 80% excited. But then automatically I'll ask the question, yo, what is your adjusted R square? And you check that adjusted R square is 0.5. Then obviously I will say, why there is a huge difference between R square and adjusted R square. So you have to protect, you have to defend. And definitely for every research, there are some limitations. So this is one limitation. So what is the limitation of this? When there is a huge gap between R square and adjusted R square, limitation is your sample size is not enough. Your number of variables, that is the number of independent variables, are not enough. So that's why we need some number of adjusted R square. Now, so there is I'm telling you, since your online session in the structural diffusion modeling, so to that part I will give some concepts. That one thing is very, very important in the research. Number one is what is the sample size. What is the sample size? And there is so many literatures that how we decide or determine the sample size. But those who are doing the primary data research, the sample size is very low. And there are so many literatures, they are telling that if you start with the private data, so you have to collect minimum 380. But I am telling this is not the perfectly correct. Because sample size depending on the domain. Because suppose if you doing some research in such a domain, maybe you are not getting so many samples. So definitely sample size depending on the. If your population size is a huge enough, so what the lakhs. So definitely there is the theory, minimum sample you have to collect. Is that again domain. I will come to the formula with some concept. So now already you asked me when you start with formula, there is a very interesting term. Maximum formula based on square. Already in statistics, you study total sums. In statistics, regression sums. In statistics, error sums. Simple as that means error can never be. That's why you make it. Another thing. There are basically two types of error in statistics. There are two types of error in statistics. One is the reducible error and one is the irreducible error. Now what is reducible error? Reducible error, which is in the research at hand, we are the researcher. So definitely we can reduce that. How can we reduce that? We can increase the sample size. We can modify the variables. We can modify our demographic profile. We can change our questionnaire pattern. We can increase our pilot survey. We can go for the survey design very nicely. So that is the basis of how we can reduce it. And which is the irreducible? That is the inner. Can never be. So in the today's research, we are mainly thinking how to minimize the reduce. Okay. So now your question is, that's a very good question. X and Y are the two variables. Try to understand. Now, from X, easily we can calculate mean. Am I right? How can we develop a formula? We can calculate mean. So from calculating mean, easily you can calculate x minus x bar. Am I right? Okay. And definitely these x minus x bar, some value is positive, some value is negative. So to remove it, am I right? To remove x square and taking the sum, and that is called total sum. So, and total sum of square basically we are calculating on what? That's what I will discuss with you. So total sum. So total sum of square, there are two parts. One is the regression sum of square plus error sum. Total sum of square, there are two parts. One is the regression sum of square plus error sum. So very interesting. From this formula, try to understand, is there any idea what is your sample size? No. From this idea, do you know what is your number of independent variables? No one. So it is a debate. So then what will do that? Total sum of square is equal to regression sum of square plus error sum. We divide both sides by total. Both sides. Is it clear? Divide both sides. Divide both sides by total sum. So what do you get? This part equal to 1. This part equal to 1. Regression sum of square means my model. My model, that means how much explained? How much explained? So it is nothing but R square plus ESS by ESS. Now what is R square? R square equal to 1 minus ESS by ESS. So just you check the formula. In formula of R square, no sample size is given. How many variables you are using for your study, that is not given. That is no concept about degrees of freedom. But if the formula, if you write what is your sample size, what is how many variables, independent variables involved, is it okay or not? Then you get some formula attached. So what is adjusted R square? Adjusted R square, it's remember adjusted R square is equal to 1 minus ESS by n minus k minus 1 divided by TSS by. Divided by n minus k minus 1. N. ESS by n minus k minus 1, TSS by n. That's what is n? N is the sample size. Total how many samples are 100, 400? What is k? Number of independent variables. In some cases you are taking 1 independent, 2 independent, 3 independent and so on. Clear? So that is the formula. And if there is a huge difference between R square and adjusted R square, then that is the problem. So that means you have to improve your sample size, you have to improve your independent variable. Maybe there are so many hidden parameters involved in your research. Initially, you have not considered.
Sir, if you could please repeat that n minus k minus
N minus k minus 1.
K.
What? K is the number of independent variables.
Thank you, sir.
Number of independent variables. This is very, very important. Is it okay? Huh? Actually, it means your sample size is very less. No, sample size is very less. Maybe your number of independent variables are very less. Because I am giving a very simple example, then you can understand. The selling price of the house, then you will understand. Selling price of the house, I am writing this example. That is selling price of the house is a function of size of the house. Very interesting. Selling price of the house depending on the floor area. Your size increases, selling price decreases. Size decreases, selling price decreases. So obviously there is a positive association. It is obvious. Is it okay? Now we collected some data from Durgapur. It's a Bandopadhyay. Some selling price of the house. Say 20 houses. And there are size of the house. And plot in the software. The real case study. Plot in the software. And naturally, when you plot in the software, we get the value of R. We get the value of R. And from the value of R square we get, say, 0.66. So what is the interpretation? Interpretation is that only 66% of the selling price can be explained by the success. So 34% unexplained. Is it okay or not? So automatically researcher will ask how you can improve your R square. So try to think of it, try to search. Is there any other hidden parameters involved for finding the selling price of the house? Is it okay or not? From the research domain, definitely. So then I am thinking, yeah, for the selling price of the house, there is one variable is involved, that is called, year of the house, age of the house. If the house is very old, selling price will decrease. If the house is new, the selling price will increase. So we consider another parameter, that is the age. So initially we start with the bivariate analysis. Single dependent, single independent. But we checked that the bivariate analysis is not enough to determine the relationship between the dependent and the independent. Is it okay or not? So you go for the other variable, definitely from the domain. So what is the domain variable? Age of the house. And if we take age of the house, automatically R square jump to 0.91. When I start SPSS, I will show you these results. Already I have given you the data set. Okay, so just to try to change, what is the change of R square? 25% increase. Why 25% increase? Because we increase the number of independent. Definitely, yes. When you consider the primary data, that one parameter is set. When you consider the secondary data, then we are going to give the cutoff. That's what I discussed. Or the parameter is set. That is very important. Otherwise, when you study the many multivariate analysis, so we have to set the value. And problem is in the real life. Problem is, our objective is to find a model. So when you go for model building, so for any kind of model there are some assumptions. And most of the real data will not satisfy the assumptions. This is the real point. But how you can get a solution? And for the getting the solution, the model divided into two parts. One is called exploratory. We need to explore, analyze the predictive. So for the exploratory model there are some assumptions, and for the predictive model there are some assumptions. And in the predictive model, assumption is less. Because in most of the when you solve the structural equation modeling, basically these are the predictive. Because if you apply all the assumptions, your research will stop. Because maximum real data will not satisfy all the important. Question is why? Because I am telling you, in most of the cases, there are some interrelationships. That part I discussed. This is a very good question. Is it okay or not? So now, so I'm giving a very interesting idea. Since today you are doing research, you try to understand the two terms. One is the supervised, and another is the unsupervised. This is very important. So, from this supervised, we understand what there is a supervisor. Unsupervised means there is no supervisor. When there is a supervisor, it means there is a master. Unsupervised means there is a PhD. Okay? So that means supervised learning means when there is output as well as input. That is supervised learning. Okay. And what is unsupervised learning? Only the inputs. Now what are the examples? So we study the regression analysis. In the regression is the supervised learning. Because in the regression analysis we know what is my output, what is my input. We know what are the y values, what are the x values. That is the regression. Is it okay? So I am giving a very interesting, just you follow my hands, then you can easily understand. So this is the left hand, this is the right hand. So naturally if we give this, what is the meaning? There is one finger in left hand, one finger in right hand. It's nothing but a simple relation. There is one dependent, one independent. Is it okay? If we, this is, what is the meaning? One dependent, because left hand is the dependent. One dependent is more than one independent. Multivariate relation. And if we this, more than one dependent and more than one independent, canonical relation. So what are under canonical logistic? Discriminant analysis, support vector machine, tail and never. That is more than one dependent, more than one. So naturally when you start your research, you have to understand what type of thing you are doing. We are doing supervised learning. Because these all are supervised learning. Because all are in case of unsupervised only. Now the problem of research is, how to determine the features. Suppose, when you start your research, you collect, I am giving a very interesting case study. Recently, I am trying to solve. There are total 1,13,000 data sets. 1,13,000 data sets. And 181 variables. So, is it feasible? All 188 variables are independent in nature. So definitely out of 181 variables there are some similarity exists. So how to find the similarity among all the variables? Am I correct or not? So how to find the similarity? There are some methods, that is called dimension reduction. How to get the similarity? Maybe out of 181 variables, initially we have collected, but all variables are not important for my study. We have to reduce it. So how we can reduce it? These are the main important part of the research. So first I'm telling you, don't write the methods first. You write your objectives. So these are my objective of my research. And on the basis of objective, then we select this suitable methods. Is it okay? Don't go to the methods first. Maximum what we are doing, I am also doing wrong. I am searching for the methods first. Don't. First you write your objective, automatically. Maybe method is the complicated, that is another issue. So there are so many literatures, so many scope of database, you will get the paper for studying that. But first you find your objective. Now, so today actually I will show you the case in the second half based on scores. So what is supervised learning? When there is dependent variable. But since due to the 2 days time, I will show you only the two cases. One is the one dependent, one independent. This is the one case. Another is the one dependent. Is it okay? And I will show you that when the supervised learning failed, in some cases your supervised learning will fail, your regression failed. So you have to know that what are the reasons for failing these methods. You have to know this. So why the regression is failed? You write here. And that's why we select the other methods. So when you switch over, try to understand, when you switch over from one method to one method, we have to know why we are switching. Is it okay? Why are we switching from factor to cluster? Why are we switching from, multiple iteration to hierarchical iteration? You have to know that. Up to this okay or not? Any question? So I'm giving the summary part that R square is very important. So what is the difference between small r? Okay, better. I'm giving a very interesting. C term is very important. If I ask you what is the meaning of central correlation? Number one question. Number two question, what is the meaning of multiple correlation? And number three question is, what is the meaning of partial correlation? So these three questions I am trying to give. I can repeat. What is the meaning of simple correlation? What is the meaning of multiple correlation? And what is the meaning of partial correlation? Is it question? Suppose there are two variables y and x. Two variables y and x. We get, say, r of yx. That means when we are finding the correlation between y and x, that is called simple correlation. Is it okay? Only two variables. This part you have to do. Now I am coming to this part. Suppose y, x1, x2. That is one dependent and one independent. Now we are right. One dependent, one independent. So try to understand. There are so many textbooks. They are giving some dot. So definitely, before dot put 1 and after dot put 2. So what is the meaning? Before dot 1, that is the dependent variable. And after dot, these two are independent. Is it okay or not? So then it is called multiple correlation. So multiple correlation means one dependent, more than one. That's multiple correlation. Now, which is very, very difficult, that is called the concept of partial correlation. So what is partial correlation? Say, if I say r of 1 to dot 3, can you tell me what is the meaning? Relation between 1 to when the effect of 3 is nil, independent. We are not considering the variable 3. We finding, try to understand, we are finding the relationship between 1 and 2 when the effect of 3 is nil, independent. No effect. So that is called the partial equation. And most of the real life structural equation, everything based on partial. But it is multivariate. So again I am repeating, there are actually basically another type of correlation that but I am not discussing today, to some extent complicated, that is another is called semi-partial correlation. That is basically used in hierarchical relation. That part I am not discussing. So I am discussing, we need these 3 things. One is the simple correlation, partial correlation, and multiple correlation. Okay. Now, I am giving a simple example, then you can understand. Say, selling price depending on some advertisement. Are you agree or no? Do you agree? Advertisement. We can go for advertisement in the different media. We can apply television, we can apply newspaper, we can apply radio. So these are called the advertisement media. Is it okay? So selling price is a function of TV, newspaper, and radio. Okay. And we go to the market. We collect the 200 market data. Better to say 40 market data. 40 market data. For each market, there are 200 observations. Try to understand what is the data analysis, what is the research. There are total, again repeat, there are total 40 markets, and from each market we collect the 200 data. So what is my data volume? 200 into 40, that is 8,000. This is the total data. So now this is the multivariate. So we want to find that what is the relationship between TV and newspaper when the effect of radio is nil. Is it okay or not? Now we want to find the selling price depending only on TV. Only on TV, simple correlation. Selling price depending only on newspaper, simple correlation. Selling price depending only on radio, simple correlation. Am I wrong or right? Selling price depending on TV and newspaper, multiple correlation. Is it okay or no? Selling price depending on multiple correlation. Now I want to find selling price, try to understand when you take some multivariate data, the problem will occur. When the selling price depending on TV, when the effect of newspaper and radio is nil. So how can I find it? That is the question. Say this is 1, this is 2, this is 3, 4. I am giving the name. So I have to find R12 dot 3, 4. What is the meaning? Then we are trying to find the correlation between selling price and TV when the effect of NP and R is nil. That is the concept of partial correlation. But in the real life scenario, when you find the correlation between selling price and TV, R12, obviously there are some effect of NP and R. That's why simple correlation will give not the clear picture. And in the multivariate, we consider the partial correlation. This is one thing. Another thing will face a problem in the real data, that part I will solve. Say, there is an assumption. So what's the assumption? The selling price in relation with the TV, selling price in relation with the NP, selling price in relation with the radio. Then you can say, now how can I find it? No, with the correlation matrix. Simply with the correlation you can get it. Now problem will occur. Say this is x1, this is x2, and this is x. Okay. But in the real life, there is a relation between TV and newspaper. Interaction. So x1 and x2, there is a high correlation. That will occur in the real life situation. The high correlation between x2 and x3. Is it okay? So this is one problem. Definitely I'll show you how can it solve. Another problem, what is it? So out of three media, next question is which is the most important media for advertisement to increase its supplies? Is it okay? Which is the most important? So that part we get from the regression. So out of these three media, which will take the most important? Is it okay? So definitely, why? Because if we check that TV is the most important, so definitely the organizer, manufacturing unit or anything will invest maximum money in that. This is the one application. The most next application is from the data set which media is not at all efficient, not at all important to remove. So that's why there is a very interesting term is called feature selection. So in case of machine learning, we are taking the features. But in case of our social science research, we are taking the variables or attributes. So which variable or attributes are important? But when you go for the machine learning research, you select the feature. Which feature is important? So that is, we can, if the name is the feature selection, which feature is important? Another. And important means which is not important. Suppose, say, newspaper is not important. So then, from the analysis, we check that the TV is important, radio is important. Then automatically, the question will come in. So you are saying important. Then how much will invest for the TV advertisement? And how much will be invested for the radio? This is the most important one. Question is why? So we like to invest say 1 lakh rupees. So from the regression analysis, it will decide how much we invest in the TV and how much we invest. So there are so many objectives you have to write, not, and that is all statistically based on data. And all results will coming from your data set. And the problem is the data set is the dynamic. If you change the data set, your interpretation will change, your results will change. Another problem is when you start with this, because today is not possible to do for me. When you go for analysis, there are basically, three types of analysis. One is the cross-sectional analysis, one is the longitudinal analysis, and one is the panel analysis. So basically, we are, for the 2 days class or the 7 days workshop, we are going for only the cross-sectional analysis. Question is why? Because we are considering the data set at particular point of time. Particular point of time, if we change the time, our data set will change. So that is basically a longitudinal time series analysis. And when you combine both the longitudinal and cross-sectional, that is the panel. So that is also the extension of the research. So when you go for cross-section, so when you research, if you understand, I will show you from my previous class. So this is my limitation and this is my feature. Is it okay or not? Why? This is the limitation of, because I have studied only the cross-sectional, but it is a time series analysis. That is my limitation. Obviously, there is a feature. Is it okay or not? Always you try to, Another part, lastly, before lunch, because I think you are tired. Last part, 5 minutes. 5 minutes. 5 minutes. I know, 5 minutes. Basically, when you start deal about model, I'll 5 minutes. When you deal with the model, this is a very, very important part. So these are divided into two parts. Any cross-section, any longitudinal any model. So what are the two parts? One is the linear and one is the non-linear. Okay. Basically, we are solving linear. Basically, we are solving linear. Not even linear. Basically, we are solving linear factors. But in most of the real life cases, it is not linear. But now you can ask the question, why you are not solving non-linear? Because it's to some extent complex. So, non-linear divided into two parts. One is the intrinsic. Intrinsic. Another is the path. Intrinsic and path. Now, what is the meaning of it? Try to understand the meaning. Say, if I ask you, y equal to a plus bx, then you will say, sir, it is the linear equation. Am I wrong or not? This is a linear equation. If I say ask you y equal to a plus bx plus cx square, can you tell me what is this? Well, it is linear. This is called intrinsic. One question is why it looks like non-linear, but if we apply some transformation, it becomes linear. I'm giving simple examples, then you can understand. Say I have the data set y and x. This is very much important for your research. Y and x. This is some data set, this is some data set. Now, we put x square, that is squaring x, we get x square. Squaring x, we get x square. So this is one data set. Suppose, try to understand, what is the coefficient of x? Very good. What is the coefficient of x square? So when the coefficient of the variables are linear in nature, that is linear. What about this is the polynomial function but still linear. Because the coefficient of x is linear, coefficient of x square is linear, coefficient of x cube is linear. But if I write this, y equal to a plus b square x plus c square x square. Can I write it? So this is the non-linear. Because the coefficients are non-linear. Question is why we can apply least square method or linear method. You know that we are applying OLS, ordinary least square. So ordinary least square method applicable for the linear system. Only applicable. So don't be confused. So I am thinking you are tired for your lunch. So next. Thank you. Because my time is 1:45, 5 minutes excess.
এই অবধি মোটামুটি হয়ে যাবে সবাইকে মানে কিছু হয়তো শেয়ার করতে হবে।
Okay, we will now take a lunch break and we will be back by 2:30 p.m. here, okay? And kindly move to the FNS department in the main building to have your lunch.